Right. So yesterday we did law of sines, part 1, okay, where we looked at 3 different types of triangles: angle, angle, side, side, angle, and side, side, angle. Side, side angle is the only one that you have to worry about the second answer or no answer, and that's the type we're going to start with today. Okay, so just a review of law of sines. So the sine of alpha over A equals sine of beta over B, which equals sine of gamma over C. Remember, we don't use all 3 parts at once. We're either going to use the first 2, the last 2, or the first part and the last part. All right, so let's try this one. A is 6, B is 8, and alpha is 35. Usually, if you can't visualize it, the first thing you should do is sketch it to see if it's one of the types of problems that you use law of sines for. Okay? But a quick way, without sketching it, is to look at the table. If you've got a row with both pieces of information, it's law of sines. Okay? If you had side, 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 then you'd be missing a piece of information in every row. And if you had side, angle, side, you'd still be missing a piece of information in every row. Okay, so we already know it's law of sines. If you have a row that has nothing in it, like this, that's a hint that it's going to be the side-side angle case. Okay. Any question why this is side-side angle without sketching it? All right, so first I want to just take a look at how the 2 solutions could happen, okay, just visually. Right, so let's take a look at this triangle. Okay, so I've tried to draw just a generic scalene triangle. Right? And this is something that it's going to be kind of hard to copy into notes because I'm going to do stuff on the smartboard, but you can try to copy it down. Okay, I want to make a copy of that triangle. I'm going to keep 2 sides and an angle the same, but it's going to look different. First thing I'm going to do is copy that side. So that's exactly the same as the other side. Then I'm going to take this side, I'm going to copy it, and I'm going to reflect it. Did that change the size of it?
No.
No. So I still have 2 congruent sides. We'll move that there. Okay, we'll move that there. So that's the same as that. That's the same as that. And the other line is horizontal. So I'm just going to draw that in. And move that up. Okay. So that angle is exactly the same as that angle. If you wanted to double check it, you could just kind of slide it over the figure and see. Okay, those 2 angles are identical. And the 2 sides I marked are identical. So there's 2 different triangles, okay, but they have a side, and an angle in common. So visually, that's how you get 2 different solutions. Okay, any question on that? That's how it can happen. If I were to give you, say I actually gave you like materials to build a triangle, and I gave you any of the other types. I told you 2 angles and a side, or 3 sides, or 2 sides and an angle. You would not be able to make 2 different triangles. Everybody's triangle, when they built it, would look the same. Okay, but these you could build 2 different ways. All right, so let's take a look at this problem and see if it does have the 2 solution, or it could be 1 solution or no solution. All right, what's the first thing I have to solve for? I don't really have a choice. Right, I have to find beta. Can you give me my proportion?
It would be sine 35 degrees, e over 6 is equal to sine of beta over 8.
Beta over 8. Okay. And the variable we're solving for is an argument to a trig function? So anytime you have that, you've got to use inverse trig. Inverse trig can have two answers. Okay? So sine of beta is 8 sine 35 divided by 6. Take the inverse sine of each side. Those cancel out. And we'll type that in. And we'll get one answer. We'll round it just like we did yesterday to three decimals. Okay, make sure you're in degrees. And type 8 sine 35 divided by 6. Okay. Just by looking at that number, how do I know I'm going to have at least one answer now?
Because it's under 1.
It's under 1. If that number was bigger than 1, then I'd know there's no solution. So take the inverse sine of that answer. And that's one answer. 49.886. Okay. How do we check if there's a second answer? Yeah?
You have to get out the table of the quadrants where the sign is positive.
Yep, so we're looking for where 0.76, that's a positive. Where else is sine equal to a positive? Second?
So you'd subtract 180. 180 minus 49.886.
Yeah, 180 minus 49.886. So if there's another answer, that's what it would be. 130.114.
So when you're writing that, would you just put that next to beta? You'd put like 49.886 for 130?
Yeah, I'll show you. We'll put it right here. And what we'll do is we'll call it beta 1 and beta 2. Does that second answer work, though?
If gamma was very acute.
Well, gamma doesn't really affect whether or not the 130 is going to work. It's more on alpha.
Yeah.
So if you look at alpha, alpha is 35. Gamma is 130.114. So if we add those together, you get 165.114. So this is not too big. If this angle was bigger, it might add up to more than 180, and then it wouldn't work. Okay, but this time it does. Any question on that? All right, so now what I want to do is write this as beta 1, beta 2. And that means we're going to have two answers for everything. Everything we're solving for. Gamma 1, gamma 2, C1, C2. There's only one answer for the given information. Okay, that was given. Okay. Now, this problem isn't really more difficult, it's longer. We have to do the problem twice. First we'll do it with gamma 1 and C1, and then we'll do it with gamma 2 and C2.
I'm still kind of confused. Did you just take 180, subtract 49.886 from it?
Yes.
All right.
Yep. So to get your second angle, always take your reference angle minus, and then 180 minus your reference angle.
Okay, is that what you do for no.
Well, for gamma, now we have alpha, we have beta. Now we know all the angles have to add up to 180, so we can figure it out just by using that fact.
Okay.
Okay? So now, let's get gamma 1. What two angles am I going to subtract from 180 to get gamma 1? Alpha and beta 1. Okay? Even though I'm using the same table for alpha 1, or beta 1 and beta 2, they're two totally separate triangles. I'm just using the same table for the information. Okay, so we have 180 minus 35 minus 49.886. So gamma 1 is 95.114. Bless you. How about gamma 2?
84.886.
Right? And how did you get that?
180 first gamma.
Yep. So 180 minus the 35, and then
I think I did. Well, 180 minus 35, and then you take 145 and subtract it by the first gamma.
and now you're going to subtract the 130. So alpha, beta 1, and gamma 1 are all in one triangle. Alpha, beta 2, and gamma 2, they make up the second triangle. Okay? Any question on that? Okay. So now subtract 130.114. And the other answer is 14.886. Any question on how we got gamma 1 and gamma 2? All right, now we got to get C1 and C2. Okay, what row are we going to use to find both C1 and C2? Yeah. Yeah, alpha. The row with A and alpha. So that's going to be used in both. So let's set that up. Sine 35 over 6. Bless you. And what angle are we going to use if you want to get C1? Right, gamma 1, 95.114. So sine 95.114 over C1. Okay, so what will C1 equal? Just, you can give me if you did it out, or just tell me what times what, divide by what. Jameson? Yep, over sine 35. Okay, so we need to do that out. We'll do it to 3 decimal places. Generally, I don't like to use an angle that's rounded, but we did it to 3, 95.114, so it's not going to throw our answer off that much.
10.419.
10.419. Okay. Now we have to do C2. Okay, we're still going to use row A, sine 35 over 6. What's going to be on the other side of my proportion this time? Yeah.
Sine of 14.886 over C2.
Yeah, sine 14.886 over C2. Okay, so using the same kind of pattern we had up above, it's exactly the same thing, except instead of having a 95.114, you have a 14.886 in its place. So 6 sine 14.886 over sine 35.
It's 2.687.
2.687. Okay, so let's just kind of check and make sure that the biggest angles are with the biggest side, smallest angle with smallest side. Let's check the beta 1s and gamma 1s. So in that triangle, the biggest angle is 95.114. And if we look at 10, 8, and 6, 10 is the biggest side. Okay. If we check the smallest angle in that triangle, we have the 95, the 49, and the 35. 35 is the smallest, and 6 is the smallest side. If we check the beta 2s and gamma 2s, we have a 35, a 130, and a 14. The 130 is the biggest. And let's see, is 8 the biggest? We have 6, 8, and 2. 8's the biggest. Okay? And you can check the smallest. Okay? 14.886 is the smallest, and 2.687 is the smallest.
So now works fine.
Yep, so everything, that just kind of makes it, it looks reasonable. It doesn't guarantee we have the the right answer, but that's always a good thing to check. If you ever end up with the biggest angle across from the smallest side, something's really wrong. Something went really wrong somewhere. Okay. Any question on that? So that's the hardest case in terms of the length of time it takes. You have to do the problem. It's like 2 problems. Okay? And that's how you would set it up on a test. Okay, just give me both answers and just organize it, in some way like that. So that was our example. Okay, let's try this one. First of all, is this a law of signs problem?
Yes.
Yeah. How do you know it's law of signs without a sketch? Yeah, you have a row with everything in it. That means law of signs. If you set your tables up the way I did. Now, is it the angle side, side angle, or angle side angle? Yeah, it is the side angle because you have a row with nothing in it, okay? Which forces me to find alpha right away. And I'm going to have to use inverse sine, which right away is the possibility of 0, 1, or 2 answers. Okay. What would be my proportion to find alpha? Yep, sine 50 over 1 equals sine alpha over 2. Okay. Well, dividing by 1 on the left-hand side, that we don't have to worry about that. So all we really need to do is double each side. 2 sine 50 equals sine alpha. And to get alpha by itself, we would have inverse sine of 2 sine 50. Okay, so let's just see what 2 sine 50 is.
It's not going to work. That's 1.5.
2 sine 50. Yeah, 1.53. How do you know that's not going to work?
That's only 1.
Yeah, it's more than 1. So if you try to take the inverse sine, okay, you get an error. So what that means is there is no solution for alpha. You cannot find it. No solution. Now, normally if we had a solution for alpha, what would we have done to get beta? Subtract, yeah, we'd add it to gamma and subtract from 180. But because there's no solution for alpha, then that means there's no solution for beta. And if you can't find the angle, you can't find the side that's across from it. Okay, so that's generally the fastest kind of problem when there's no solution. You find out right away. Okay, any question on that? Okay, what I want to do now is make a sketch of that triangle. Okay, just sign up for me. What's going to happen if we make a sketch of a triangle that's no solution? It won't be a triangle. Okay? So let's take a look. Okay, what I've done is I used the protractor on the screen to draw out a 50-degree angle, okay, which represents gamma. I hope that was gamma. Yeah, gamma. And then I just drew a couple segments and I angled it exactly at 50 degrees from a horizontal. Okay? I also made this segment twice as long as that segment. Okay? Because A is 2 and C is 1. All right? So I just measured it out and that segment is twice as long. Okay, so let's put A here and then C would be up there. And B is I have to keep B horizontal, otherwise that angle wouldn't be 50. But B can be any length I want. Okay, I can make it short, long, whatever I want to do. Okay, so here's B. Why can't I get a triangle out of that? Yeah, C will never reach. I can make this angle anything I want. There's no restriction on it. And I can make that as long as I want. But I have to keep that 50, which means I can't turn that bottom side up. And no matter how I rotate this side, I mean, the best I could do would be putting it straight, well, that's not perfect, but straight up and down, and it still doesn't reach. Okay? So the problem is with side C. It just doesn't reach. Okay, there's a range of numbers. If we wanted to get a little bit fancy, we could figure out what are the values of C that would make this a triangle. Okay? So at some point, there is a minimum value C needs to be, and then it'll work. Would there be a maximum value? No, because B can just keep extending. You can make B as long as you want, and then make C as long as you want. Right? But there is a minimum value. And that minimum value would basically be what's the shortest, we'd have to find that shortest distance you could have there and still have it connect and make a triangle. Okay? Is it perpendicular? Maybe. It might be an assumption you would think that it would just be perpendicular, but we'd have to go through and check that and make sure. It might not be. Okay, but we're not going to do that. Any question on that? Okay, so that's the no solution case. All right, so I put up 2 problems for you to try. Okay, example 3 says A is 4, B is 5, alpha is 60. And example 4, B is 2, C is 3, beta is 40. Okay, so take a few minutes, try both of those, and then we'll come back together and see what you get. All right, so let's take a look and see how we did. Okay, so you should have found one with no solution, one with 2. How about example 3? Anybody think they figured out that one? Yeah. No solution. Okay, let's just take a quick look at why. So you're forced to solve for beta, okay, right away. So sine 60 over 4 equals sine beta over 5. Okay, so all we really have to do is look at 5 times the sine of 60 divided by 4. If it's bigger than 1, then we're done. Okay, we know there's no solution. Okay, so what did I say? 5 sine 60? 5 sine 60 divided by 4. It's 1.08. Okay, so it's a little bit too big. So that's no solution. Any question on that? All right, so let's look at example 4. Okay, this is the one I said that it should have 2. So we need A. It's going to have 2. Actually, let's leave a little bit more room. A1 and A2. Alpha 1, alpha 2. And gamma 1, gamma 2. Okay, what do I have to find first? Yeah, gamma 1. We can't really do anything with the top row here because we don't have anything in it. So you've got to find gamma, and you'll find out in a second that it's really just gamma 1. Okay. What would be my proportion to solve for gamma 1? Yeah? Yeah, and sine, you wouldn't know it's really going to have 2 answers, but we do. Sine of gamma 1 over 3. Right, so gamma 1 will be the inverse sine of 3 sine 40 divided by 2. You can do all that in one step. That's fine. Okay, let's see what we get. So 3 sine 40 divided by 2. It's less than 1, so I know that's how I know I get 2 answers. I just use the answer key to type it in. 74.619. And how do we use that to get the second answer? Yep.
We'll use that, add it to 40, and then subtract that answer from 180, and then we have, no, alpha.
So before we get alpha, I just want to check if there's a gamma 2.
Oh, yeah, there is going to be, because it's inverse sine.
So how do you
have
get
to
that?
do 180 subtracted by your reference angle.
Okay, yep. So 74.619. I get 105.381. I was given a 40. Would 40 and 105 fit together in the triangle?
Yeah.
Yes. Now we can do what Matt said and subtract, add up beta and gamma 1, subtract it from 180 to get alpha 1. Okay, so we've got 180 minus 40 minus 105.381. And then if someone can get alpha 2, that'll just save us a few minutes. So 34.619. And how about alpha 2? Yep.
I got 65.381.
65. Did anybody else get 381?
Yeah.
Rounded, okay, correctly. Okay, so now we've got everything except A1 and A2.
You flip them.
Yeah.
Oh, did I switch them?
Yeah.
Okay. Thank you. 65.381, yeah. And someone remind me what 34 point what?
618.
619. Okay. Thank you. Okay, yeah, you don't want to flip it. It does make a difference where you put them. All right. Now we're going to use alpha 1 to get A1. Okay, so my proportion would be sine 40 over 2 equals sine 65.381 over A1. And did anybody do that and get an answer for A1? 2.829. And then for A2, it's going to be sine 40 over 2 equals sine 34.619 over A2. And yeah, go ahead.
1.768.
Yeah, one more time.
1.768.
1.768. Okay. Any question on that one? All right, so that's your two solution case. All right, so let me put up the homework. So as I said, the one for tonight is really the bottom one because I had switched them. Okay, so make sure both of those are done for tomorrow. And I'll check both if you didn't have one today.